If you're not ready, let me know, and then I will.
Yeah.
Okay, so here we go. Quiz number 3, sections 4.5 and 4.6. The first question, hang on just a second. So the first question, see if I can do a split screen here real quick. Okay, the first question says, if a sub n is equal to 4n plus 1, what are the first 3 terms of the sequence? Okay, so we want n to equal 1, we want n to equal 2, and we want n to equal 3. Okay, so that will be a sub 1, a sub 2, and a sub 3. We want to find the first 3 terms. So basically all we do is we plug in 1 for n, and then we're going to plug in 2n for n, and then we'll plug in 3n for n. Okay, so let's try it for a sub 1. The first one is 4 times 1 plus 1. So 4 times 1 is 4 plus 1 is 5. Let's do it for the second term. 4 times 2 plus 1 is 8 plus 1. So the second term is 9. And the third term is 4 times 3 plus 1. That's 12 plus 1. So that's 13. So the first 3 terms are 5, 9, and 13. So that's answer 1. Okay? Any questions on problem number 1? I'll pause for 5 seconds. If I don't hear anybody, then I'll move on. All right, let's go to question number 2. If a sub n equals 2 to the n minus 3, what's the 5th term? Okay, what's the 5th term? So a sub n, 2n minus 3. Let me double check it. 2n minus 3, yep. Okay, so they want us to find the 5th term. This one actually is pretty easy. So just plug in 5 for n. We're going to plug in 5 for n, and then we're going to subtract 3. So 2 to the 5th is 2 times 2 times 2 times 2 times 2, which, if you want, grab a calculator and take 2 to the 5th power, or just multiply 2 times 2 times 2. You can use a calculator if you want. You get 32. So we get 32 minus 3. So that answer is 29. So the answer to number 2 is 29. Right? That wasn't too difficult. Any questions on number 2? Now you guys are going to have a test over this, over everything in chapter 4 tomorrow. So that's why I'm saying make sure you take good notes, okay? Number 3. The first term is 2, and then the recursive formula is 3 times a sub n minus 1 plus 1. What's the third term? What's a3? Okay, so let me write this down. So number 3, the first term is equal to 2, and then it's 3 times a sub n minus 1 plus 1. Let's see if I can remember that real quick. 2 and 3 times. So the recursive formula is equal to a sub n minus 1, actually 3 times that plus 1. Let me double check it. 3 times, yep, plus 1. Okay. All right, and they want us to find the third term. Sorry, I'm jumping around, but without splitting screens, it's kind of hard to see. So yes, they want us to find the third term. So n is going to equal 3. So a sub 3 equals, oh, the way to solve this one is we don't know right yet what the second term is. Okay, so if this is 3, then this is going to be 2. So we got to find out what 2 is, the second term, before we can find the third term. So we got to kind of work backwards before we can answer this one. So using the recursive formula, the one up here with the star by it, we're going to use that formula. And notice this next term is going to be 1 less. The subscript here is always going to be 1 less. N minus 1 just means subtract 1 from the n. So if this is n minus 1s. So do we know what a sub 1 is? Do we know what the first term is? Yes. Sorry, to find the second term, that's a 2. We're going to, uh-oh. Let's see here. I lost my pen for just a second. Let's hopefully, there it comes. Okay. So it's 3 times, the first term was given up at the top. The first term was 2. So plugging in the first term, multiplying it by 3, we get 6. And we add 1. So the second term is actually 7. So now that we know the second term, so far the first term was 2. The second term is 7. Now we can find the third term. We're going to take this answer here and we're going to plug it in up here. Okay, so we're going to go 3 times 7, all right, plus 1. So this is 21 plus 1, which is 22. Okay, and we can stop there. But I feel like that might still be a little bit confusing. Let me just recap, especially right here on the second line where I have the stars. This is called the recursive formula. It says to find the next term, you take the previous term, you multiply it by 3, and then you add 1. So let's see if it works. Let's multiply 2 times 3 and add 1. Yes, that gives us 7. Let's take 7 and multiply it times 3. 7 times 3 is 21 plus 1 is 22. And so we could even find the next term. So to find the next term, we would take 22, multiply it by 3, and add 1. So that would give us 66 plus 1. So the next term would be 67. So those are the first 4 terms. They only care about the third term. So the answer is 22. So a sub 3 equals 22. Any questions on that one? Okay, I kind of got you started on the right track on number 4. It tells us that the first 2 terms are both 1, okay? But then it tells us that the recursive formula is equal to, so to find the next term, we just add up the 2 previous terms. That's what that means. Okay, if you look at number 4, a sub n equals a sub n minus 1 plus a sub n minus 2. If you're interpreting it, it says to find the next term, you just add the 2 previous terms together. So if we know the first 2 terms, we can find the third term. Okay, let's see if we can. All right, so the formula is a sub n equals a sub n minus 1 plus a sub n minus 2. So to find the next term, we take the previous term and then we add the one that's before it. Okay, so if we know the first term is 1, the second term is also 1, so we have 1, 1. To find the next term, which would be A3, we just add A2 plus A1, right? Because if this is A1, this is A2, this is A3, and this is A4. So we're finding A3, so it's going to take the 1 before it, this would be n minus 1, and adding the one that is 2 before it, which is n minus 2. So that would be the first position. So let's add the second and the first one to give us the third one. So that's 1 and that's 1. So the third number is just a 2. In other words, take these two numbers, add them together, and you get the next number. So that is easy. We can actually find the fourth term fairly easy. I'm going to change the color here. I'll highlight these two. We're going to take the two previous answers, add them up, and that's going to be our next number. So the next number is going to be 3. So A sub 4 equals the term right before it plus the term before it. So that equals 3. So the answer for number 4 is 3. Okay, number 5. On these, we were just asked to identify whether they're arithmetic, geometric, or neither, or both. Okay, 3, 6, 9, 12. Number 5. 3, 6, 9, 12. To go from one to the other, we have to add 3. Okay? So that's an arithmetic because we're adding something. We're adding a common difference. So that's number 5 is arithmetic. Number 6 is negative 1, 2, 4, 8. And then the signs are alternating. They didn't ask you to define the common difference or the common ratio. But we could. Let's just make sure I get this right. So 2, negative 4, and then 8. Positive 8. Okay. I think I got my signs wrong here. Hang on just a second. So the 1 is negative and the 2 is positive. Okay. That's negative and that's positive. Okay, so to move from one to the next, if you wanted to try to add common numbers, you'll see that the numbers that you're adding is different each time. So it's not an arithmetic sequence. So it definitely, that doesn't work. But if you notice, if you take one of the numbers, like the last number 8, and you divide it by 4, you get a 2. If you take the third number and divide it by the second number, you also get a 2. And if you take the second number and divide it by the first number, you also get a 2. So these 2's are what's called the common ratios. So this one definitely has to be a geometric, and it's actually being multiplied by a negative 2. It's because the sign keeps changing, right? So negative 1 times negative 2 is positive 2. Sorry, this thing is not really cooperating at the moment. Okay, so anyway, that was geometric. Number 6. Number 7, I don't think there was any patterns on number 7. You could try different numbers, try different differences. 1, 3, 7. Let's see. I'm going to try this so I can actually see the problem without having to jump back and forth. Okay, So we got 1, 3, 7, -2, -5, and 31. It looks pretty disordered, the pattern. We can't add a common number to get to the next number. And if you look at the ratios, they're just odd ratios. There's nothing that seems to create a pattern here. So that one is really not even a sequence. It's just kind of a random list of numbers. So number 7 is neither. I think most everybody got that. Now number 8 was just a bunch of 3s. And this one is kind of odd, and that's why I gave it to you. If you were in class yesterday and listening to me talk, then I told you the answer to number 8. However, some of you still missed it. I don't really know how that happened. But if we added 0, we could get the next number. So 3 plus 0 is 3. And then 3 plus 0 is 3. So it could be an arithmetic. Or we can multiply each one by 1. Multiply by 1, and it would be geometric. So since it could be both, that's why the answer is both. Okay, now for the hard ones. The two hard ones, number 9 and number 10. We're asked to write the explicit formula for each. 3, 7, 11, and 15. Well, it wasn't too hard to find the common difference. It was just adding 4 to each one. So we're going to say D equals 4. But most likely, now I remember I told you guys it was open notes, and I had just done about 10 problems from chapter 4 review, and I said use your notes and take good notes. So I don't know if that happened, but apparently it didn't happen too well, because for the explicit formula you would need to remember this formula. For these, and this is called an arithmetic sequence, it's going to be a sub n equals the first term plus n minus 1 times the common difference. And we know what the common difference is. It's 4. Okay, and we know what the first term is also. The first term is 3. So if you wrote this, I would have probably given you credit. Okay? Now, there is something that you can do. There's a step further you can go with this if you wanted to. And that is, sometimes they ask you to simplify. And you could go ahead and distribute out the 4. So 4 times n and 4 times minus 1, you get 4n minus 4. And then, so let's add these two numbers here. 3 minus 4 is minus 1. So we're going to get 4n minus 1. So either one of these answers would have worked. That would have been a good answer. But if you would have left it like this, I would have taken either one. But this bottom one here with the star on it is preferred. Okay. So why am I letting you retake a quiz that I'm doing the answers for you? And I guess I just feel, since everybody did so poorly, I'm not going to say it was my fault, but maybe you just weren't ready for this quiz. I know that these concepts are kind of challenging. All right, number 4, or number 10, starts with 4, then it goes to 12, then it goes to 36, then it goes to 108. So if I took any two of these numbers, and I took the bigger number divided by the smaller number, so if I took 36 divided by 12, I'm going to get 3. 12 divided by 4, I get 3. So the common ratio is 3. So we multiply each one by 3 to get the next one. Now, if you look in your book for explicit formulas, and I did say you could use your book, if you looked in your book for explicit formulas, you will find this on, hang on, let me give you the page number. It's under geometric sequences. And it is on page it's on page 160. And this one's a little weird, but the explicit formula is a sub n equals a sub 1, so the first term, multiplied by the common ratio raised to the power n minus 1. Okay, so all we need to do is just plug in r, and we need to plug in our first term, which is 4. So a sub n equals 4 times 3 to the n minus 1. And that's it. That's the answer. Okay, now on this last one, hopefully you guys had a chance to write that down. On this last one, let's see if we can't maybe work together and see if we can't figure it out. Let's take the top numbers, okay, and kind of separate them from the bottom numbers. See if we can find a pattern on the top and see if we can find a different pattern on the bottom. So again, we're asked to find the explicit formula for each. So let's take the top numbers. Can maybe one of you unmute your microphone and tell me what kind of ratio is it? Multiplied by 2, okay? So what kind of sequence is that, Jonah? Geometric or arithmetic? Arithmetic. When we multiply something.
Geometric?
Yep. Okay, now let's take a look at the bottom one. What do we see about what's going on with the bottom numbers?
It's adding to.
Yep. And so is that geometric or arithmetic?
Arithmetic.
Now you guys have notes. Hopefully you took good notes on those questions. Can somebody give me the general formula for the explicit? Let me try that again. Can somebody give me the explicit formula for geometric sequences? And it was actually just like number 10. Go ahead and turn your microphone on and tell me what the formula is for geometric sequences. I'll give you a hint. I'll give you a hint. It's right here. Don't just give me the general formula. I circled it.
A(n) equals a to the first
1
times the common ratio n minus 1. You're too slow, Daniel.
Yeah. Thanks, Jonah. Okay, so you guys circle that on your paper because we're going to use it down here. Since I don't have a big whiteboard, I can't really keep both going. So we're going to use that on the top. Okay, so on the top, we're going to use this formula. Let me just sketch it down right here. So it's a sub n equals a sub 1 times r to the n minus 1. Okay, and then for the bottom one, it's arithmetic. It's like number 9. And what's the general form for the arithmetic sequences? Here, I'll help you out. I'll circle it. Jonah, why don't you read it? A sub n. Yep.
A sub n equals a sub 1 plus n minus 1 times the
D, right? So
yeah, the common or the different.
Okay. Do you remember? Can somebody read it back to me since I can't see it?
Okay, so where's this at again? What number?
Number 9.
Number 9. Okay, so it's a sub n equals a sub 1, and then so a sub n equals a sub 1 plus n minus 1 equals times d.
Times d, right? Times d. Yep. Okay. Now, looking at these sequences, do we know? Let's go to the top one now. Do we know what R is?
The
ratio or common ratio
Mhm.
or whatever.
It's times. Is it? Yeah, times 2.
Yeah, it's 2, right? So a sub n equals, oh, so yes, r is 2. R is 2. And down here, d is 2. So what is a sub 1 on the top one? What is the first term? On the top, only on the top. What's the first term?
2.
2.
Okay.
It's 2.
And what was r on the top?
2.
Times 2.
Yeah, it was also 2, right?
2.
Okay. So this right here, I'll highlight it in the pink marker. This right here is the answer for the top, okay? Now, for the bottom. See if you guys can help me figure out the bottom. What's the first number? See, I'm looking at the arithmetic sequence. I kind of have it started here. We just got to plug in A1 and we got to plug in D.
So A1 is 3.
Yep, A1 is 3.
And then D is plus 2.
And D is 2, right? So can we simplify that a little bit? Can we simplify that? Distribute. So that becomes 2n minus 2 plus 3. So we're going to add the like terms. 3 minus 2 is plus 1, right? Positive 1, right? 3 minus 2 is 1. So rewriting this, we're going to get 2 times 2n minus 1 over 2n plus 1. So that is what's called the explicit formula for this fraction. And it would allow us to find any of the following terms in that sequence given. Starting with 2/3, 4/5, 8/7, 16/9. And let's try it. Let's find, so we given the first 4 terms. Let's say we use that to find the 5th term. So what would the 5th term be? Well, we're just going to plug in 5 for n. So the bottom's easy. 2 times 5 is 10 plus 1. So the bottom's going to be 11, isn't it? And on the top, we're going to go 2 times 2 to the 4th. Can we simplify this? What do you think this top simplifies to? What is 2 to the 4th? 2 times 2 times 2 times 2. 2 times 2 times 2 times 2.
16.
16. And then 16 times 2?
32.
32. So the next term would be 32 over 11. And we could keep doing this and we could get more and more terms, but the answer that we're looking for is right here in this box, okay? Okay, so that's all as far as the quiz goes. Now, oops. Let me see if I can stop this. I was recording this for anybody that missed.